Hello class, I'm glad you can join me on this lesson today on symmetry. So we're going to talk about symmetry and we're going to use this example here of f of x equals x squared to do this. So now I want you to have this graph drawn and find your local minimum. So take a moment and make an attempt at that. Alright, so you should remember this as being your local minimum, and this is a polynomial. In this case, we actually have it as x equaling negative b over 2a. Okay, you could have also just said, since this is the function, you would have been like, wait a second, it's x squared, the local minimum is at 0, so it must be where it's 0. Well, if we use this form, right, this is for any polynomial, if you remember, it's going to be, in this case, p of x I'll use, is equal to ax squared plus bx plus c. And we can take these integer values and plug them in, so forth. So we could have had any sort of function and find our local minimum. So answer here, the local minimum is when x equals 0. Beautiful. Now, how does this help us? Well, this is actually a really interesting idea to say, you know, if I put a line down the center, right, while we're at this minimum, right, notice if I folded this over, right, my drawing's not great, but if I folded this over with this arm over here on the left, or this arm here on the right, that if I folded it and brought it over, this whole arm would mimic the other side. This mimic on the other side is very important. We should note that basically this mimic, or mimicry I should say, means that this function has symmetry. And we call this an axis of symmetry. So axis of symmetry is the basic definition that any 2 points that you pick along the graph will be parallel, creating, along some line L here, this axis. So let's rewrite that in a paraphrase to say that both sides of the graph mirror each other. And this is not a term that's saying that this is generalized, that this is generally mirroring each other. They exactly mirror each other. So that's your axis of symmetry, which occurs at x equals 0. Alright, let's consider another quick example. So for this example, we're looking at this graph g of x equals x cubed, and we're looking at it graphed along this coordinate grid here. Well, use your imagination. And does the function of g of x equals x cubed, so this function here, have an axis of symmetry? Well, I would say just simply try it out. You can end up using this definition right here. Both sides of the graph mirror each other. Well, if you try that here, let's just say, you know, where is it going to be a point that's pivoting, or I would say some central point. I'm going to look at right down the middle, because x cubed here, it's pretty easy to see some sort of symmetrical values from here, this arm to this arm, but they're not mirroring each other. They don't overlap if you rotate about this axis, nor here either. They don't mimic. They have to overlap. They have to, just like above, they have to overlap each other or overlay each other when you reflect them. So in this case here, no, it doesn't have an axis of symmetry, so no axis of symmetry, but it does have a point of symmetry. So you don't have to write all this part out. I just wanted to bring it up to this here, this next statement, to say it has a point of symmetry. And I'm going to write this in to state that actually a polynomial, Trinomial function has the setup to say, let's do p of x, and I'll do this in green. P of x is equal to, in this case, ax cubed plus bx squared plus cx plus d. Oh my god, another variable? It's okay, you'll survive. And I want to say that actually this doesn't work to find the point of symmetry. This finds the line of symmetry for a quadratic, but here to get a trinomial, or sorry, this would be a quadnomial. I can't think of the name right now. But basically, if your power of your function is 3, right, you're going to have x cubed, x squared, x, and this integer values. You can say x to the 0 here. The way you're actually going to find this point of symmetry is actually going to be something very similar. It's going to look like x equals negative b over 3a. And this value, if you do it out, you're actually going to find this point of symmetry, which is right here. So I'm going to put that in green. That is your point of symmetry. So how does this help us, and where does this get applied? Well, let's do a question and test it out. So for this one here, I want you to use symmetry to sketch this graph here. Y to the 4th equals x plus 1. Feel free to start by doing any steps that you would want to try and graph it, let's say along this coordinate grid. Alrighty, so with this, the symmetry to sketch this, or the method of using symmetry to sketch this, is this idea that first off you're dealing with y to the 4th equals x plus 1. Not a great way to look at it. So I would actually write it as y, take the root of x plus 1, but this is the 4th root. And note that when you do this you get positive and negative values, right? That's important for here. Note, I've been saying before when we're graphing this, it's not going to be a function when you graph it because you're going to have this and this value, because when you do that you're going to get along the lines of saying that if it's plus 1, right, you're going to go over, translate it here, because it's, and I want to just note it's inside the function, it's lying to you. So here, start over here, and it goes something like that. That'll be this function, okay? Now, the other part of it would look like this. This is the negative side. Do we note that there is some symmetry between this arm and this arm? Well, yes we do. We note that there is symmetry and that we don't need both parts when we have the understanding that there is symmetry of this line here of y equals 0. Now, if you wanted to actually graph both of them to get both these arms, I would not put this in your calculator to do this. What I would suggest is graphing these as two different parts of the function. This arm here, the positive bit, and the negative portion, this portion here. And that will give you both of them. Alright, so that was the end of this lesson. Just wanted to give you guys some value of using symmetry and understanding where it comes from. I hope you enjoyed this lesson. I look forward to seeing you all next time.